Hi guys, so in our previous video we looked at number base, introduction to number base as a whole. Then we moved to um, converting from other bases into base 10. We said we looked at the binary system, how to convert from the binary to decimal, how to convert from octal to decimal, and we said it was just basically knowing how to understand the bases, their leaves, the positional notation, and how to write them in expanded form, knowing how as you go from the right to the left, the powers increase. So in this video, we're looking at quite the opposite, how to change from a base 10 system. As we can see, this number is in base 10, 20. So I wrote the subscript 10 here to make it very clear, but in some cases you might not see the subscript there, and when you don't see the subscript, you know that you are still in a base 10 system. So but if you're in a base 2 system or base 8 or any other base apart from base 10, the subscript will be given certainly, or it will be written like this in binary. So but for a base 2 system, I believe it's already very clear that a base 2 system has 0 and 1. So when we see a number like 101, 111, we know we're in a base 2 system. So but I want to point out that if we see a number like 101, for instance, in base 2, it should not be confused with 101 in a base 10 system. 101 a base 10 system. So the reason is simple. The reason is because in a base 2 system, the position the each digit is arranged under placeholders that are different from our normal unit, tens, hundred. This is a base 10 system. We have units, we have tens, we have hundred, just as a recap. But that is why we say 100, 0 tens, and 1 unit, 101. But in this case, we have our units, we have our twos place, and we have our fours place. So I explained this in the previous video anyway. So for a number like, I want us to go straight into this example. We have 20 base 10. I will show you a simple method, and I will show you another method which is most commonly used. If we understand the concept of writing numbers in expanded forms, we can see that converting this 20 to binary can be done even with, let me just say, right off of our head, with the normal understanding of how a base 2 system works, or how different it is from a base 10 system. Now let me say we know that the base 2 system goes from units, like I said, from units to twos. I will just put that like this: twos to fours, to make it easier, to eights, to 16s. I'll just put it like this. And we even have 32s if you keep going. So it's just all these are powers of twos. Even these units can be written as ones as well. Good. So if we want to write, then we know it have two leaves as well, 0 and 1. If you want to write, we could just express this 20 as a sum of two numbers, and those two numbers must be among these groups. So somebody can say 8 plus 8 plus 2 plus 2. Somebody else can say, let me just change the color. Somebody else can say um 16 plus 4. So I will just use these two as my example. Now I'll write something else just so that I can use it as for further explanation. 10 plus 10, like that. Now if you compare these three that we are having here, I'll tell you the one that is completely wrong. 10 plus 10 here is wrong, for that is as an to explain this 20, or to as the expanded form of 20. Why is it wrong? Because this 10 is not among the groups or the placeholders for a base 2 system. Now, so I just put X there. In this case, 8 plus 8 plus 2 plus 2. Now we have groups of 8, we also have groups of 2's here, but still it's wrong. And the reason it's a wrong it's a wrong expansion of this 20. I'm just trying to do like use a reverse method of what we did, because remember the previous video we were using a method of kind of like an expanded form to change from other bases into base 10. So this is wrong, and if you think about it, it's because we are having two eights and we're having two twos as well, and we know in a base 2 system you cannot have two. So it's like somebody writing two here, write two under here, and write two under here. You can see that it goes against what makes a base 2 system a base 2 system. A base 2 system can only have 0 and 1. So in this case, this is the correct expansion. 16 plus 4. 16 is one of the groups or one of the placeholders, one of the positions in a base 2 system. 4 is also another one. So I'm going to have one here. I'm going to have one here. Now, the rest placeholders, I'm going to fill them up with 0. So my answer is just simply 1 0 1 0 0. Now, second method I'll use before I end this video is called method of successive division. Let me just use my line tool to put a straight line here. Okay. All right. So I have something like this. Good. We will keep our 20 here. Remember, we are still looking at 20. Keep our 20 here. Let me just take it up a bit. We keep our 20 on the right hand side, and we are going to be dividing by 2. This method, like I said, is called successive division. Just write it here. Successive division. So it's the word successive there has made it easier for us to understand. When we say successive, it means we are going to continuously divide by a number, in this case by 2. And the reason why 2 is picked is because we are in a base 2 system. And if I divide something by 2, it means I want to have groups of 2's. If you divide 2 by 20, you have 10. Yeah, 10. So it means I have 10 group of 2's. Or it's like or it's like you're sharing something 2 per person. 10 people will have their shares of binary, or their shares of byproduct or something like that. So but for some reason we are going to be writing the remainders. Here we have remainder of 0. I will explain why it is a must for us to write the remainders. We divide by 2 again successively until we have 0 left. We have 5 remainder 0, have 2 remainder 1, you have 1 remainder 0, and you have 0 remainder 1. Now the remainders here, which is 0 0 1 0 and 1, those remainders are our answer, but we are not going to read them from the first one. Instead, we are going to read them upwards from the last one. So I'll just use my line to put an arrow, something like this. Exactly. So something like this. We read it from down to up. So our answers, if I write them, our answer is just like what we have here. The last one is 1. The remainder is 1 0 1 0 0 in base 2, and this is our answer. Now, conceptually, when you look at it, it makes sense, because this the first remainder here is the value we had here for our units place, and we can explain that by saying when we initially said 20 divided by 2, we had 10 group of 2's and we didn't have any units left. So if there were to be like 1 unit left, we would have been having 1 here. So it makes sense, or it is safe for me to say that this is my unit place, that the first remainder here is the remainder for my units, and I have 0 units here. Now, 10 group of 2's was useless to me in a base 2 system, because a base 2 system has only 2 glyphs. So like we can have 1 2's or 0 2's. We cannot have 2 2's. We cannot have 4 2's. We cannot have how much more 10 2's. So we had to keep dividing. We say 2 goes in 10 again, and it gives me 5 remainder 0. Now in this case, it's like you already had 10 group of 2's. I don't want to draw 10 group of 2's, but we can just imagine having 10 group of two balls each, and we divide by 2 again. So it's like each is like you're now taking among those 10 group of 2's, is like you want to divide it by 2 again. So dividing 10 group of 2's by 2 is going to give you 5 group of 2 2's. which is actually five group of fours. Let me just, I think I won't draw all, but I will just draw a few of them. It's one, two, three, four, five, six. So just imagine we have others, seven, eight. Good. So we'll have 20 like this, and this is one group. Just change this to black. Okay. This is one group. This is another group. This is another group, and like that we have 10 groups like that. So if we want to divide this by two again, it's like saying this two becomes one, this two becomes two. You get what I'm saying? So it's like we are now sharing each, merging two groups together. So it's now like instead of one group of twos, now we're now having one group of fours. In this case, it's two group of fours. So the five we have here is five groups of fours, not longer five group of twos, because initially here we had 10 group of twos and we're sharing it into two again. So it's like two, two, and two of two makes four. So this is five groups of fours, remainder zero group. Now, if you think about it, it's remainder zero group of what? Now, don't be confused. It's not longer a unit remainder. Here, it's a twos place. So any remainder we have is under twos, because you can imagine we initially had 10 group of twos, so no longer ones. So the 20 here were ones, the 10 here were twos. So any remainder that moves to the next line is also twos. So remember, five group of fours also, even though we have a group for fours, as we can see, it does not make any good sense. We can't use it. Why? Because we can only have one fours or zero fours. You can't have five fours in a bestow system. So we keep dividing. You divide by two again. So once you divide by two, you have two groups of not fours. If you think about it conceptually, you have two groups of eights, because you are now like, when you divide by two, you have two of fours make eight. Two fours make eight, and when the two we have in here is now two groups of eight, remainder one. Now the remainder of one here, if you think about it, is not a unit remainder. It's one group of four. It's a group that consists of four items, four squares in this case. Remember, we already had, let me just use another color. We already had five groups of fours, where this is like one group of fours like this. So just like that, and this is a fourth place. This is a fourth place. So if you keep doing it, you can see that as we move from the first one to the last one, our each of these our remainders are increasing in increasing in powers of twos, from units to twos to fours. This one, conceptually, when you reason it the way I explained, this one is going to be eight, and the next one will be 16s. So my reason for telling you this is just to explain, because some people might be like, why do we have to take our arrow from down to up and not from up to down, or why do we have to actually keep dividing? So this is the main reason. Thank you for watching.